The first presentation then is going to be about COGS, bills, material, payment terms, cash flow. So sort of the very boring but absolutely vital to an actual functioning business. So it's actually quite important. And when we deal with a lot of startups here, a lot of new entrepreneurs, and most of them are technical people, most of them are pretty smart. This is one of the areas where they really run aground in, and they're just completely shocked when they finally get a product, they finally get to the point where it can be manufactured. And one of the things that will kill them faster than anything else is if Target or somebody comes along, sorry about that, and says, sure, we'll buy 100,000 of them if you can get them to us in 10 weeks or something like that. And 100,000 units, if cost of goods is $30, there's $3 million right there that you need up front. And then, it ships 12 weeks later. It takes 5 weeks to get across the Pacific. Target pays, I'm not picking on Target, but they might not pay for 90 days. Like 5 months has gone by and you're going to carry that $3 million. If it's a big success and you have more and more and more orders, you're going to come up with millions of dollars just to build your inventory. And a consumer products company that makes 10% before taxes is a really well-run company, and 10% is not enough to grow your business just for the cost of growing inventory. If you have to carry inventory for 6 months and you make 10% in the bottom line and your gross margin is 50%, if you plow all your profits into inventory, the best you can do is 40% a year. The reality is you're also hiring salespeople and running bigger buildings and hiring more engineers and customer support. And so this is why when Pebble, who was one of our clients, raised $10.3 million on Kickstarter, a record at the time, and they started working with us to build it. And one of the first things they did was go out and raise $15 million of additional funding. Because whereas the Kickstarter funds would have taken them through the first 85,000 units, I think it was, they eventually had 250,000 total, including back orders by the time we shipped the first one. There's no way they could have shipped all those other products without raising additional money. So money is really, really important. And it's really all about cash flow, having the cash to pay your bills. Okay, so project management triangle, cost is very important. So schedule, so is quality. And so you can usually, you can almost always get one of these. You can usually get two if you work hard and you're good. It's almost impossible to get all three. Somebody comes and says, okay, we get this product, the engineering's not done yet. It's going to be as cheap as possible. It's got the usual 8 or 9 months to get out of the factory. We need it in 3 months. And that stuff just is not going to happen. Cost of goods sold. These are the direct costs for the goods produced. You can think of it the cost to manufacture it in the factory, and it does not include things not directly associated with manufacturing the product. So your salesman's salary, insurance, the cost to run your office here in the US, stuff like that, not included. So it's materials and labor and so on, everything you pay the factory for. And the price to some extent depends on where you take ownership. Because while the factory is building the product, it probably belongs to them at that point. It can be ex-factory. This means that when they're done and it's inspected and signed off, they move it out the loading dock and it magically, legally becomes your product. Which means you have to have your freight forwarder as your representative there at the loading dock to take possession of the goods, and you better make sure he carries insurance, because if the container's blown off the deck of the ship, and it's happened at one company I worked, you better have insurance to cover it or you're out the cost of how many hundreds of thousands of dollars that container worth of goods cost you. FOB, this is freight on board. It means the factory owns it up until the point it's actually on the ship. So they'll truck it to the ship, they'll arrange for it to get loaded. The difference in cost is actually very small. It's pretty cheap to haul a container from the factory to the port, because the factories we work with anyways are very close to the ports. Landed, this you will almost never get. This means they own it all the way till it lands in San Diego or SeaTac. But the factories we work with, they're not shipping companies, so it's those first two are right. In some cases, you might not take ownership until it's in a warehouse. Again, with the factories we work with, that's pretty much not going to happen. I wouldn't be surprised if outfits like PCH would offer you this, because they offer a more complete package where they'll do fulfillment and things like that. So some companies might offer that, but it's really uncommon. Prices can vary over time. You make engineering changes, whether for enhancements or for safety reasons to fix problems. Transportation costs change, especially with oil. Material costs sometimes change. All the resins, all the plastics are made from resins that come from petroleum. The fact that oil has been collapsing lately is good news for American purchasers of manufactured products in China. It means the resins are going down. currency exchange rates change. The Chinese currency has been, for the most part, gradually trending up, and relative against the dollar, and this is actually bad news for us because it makes Chinese manufactured products more expensive. And bad news for China as well, because American companies and others are starting to move some of their business to other countries. Very simple costing model. So you have the cost of goods that we talked about. That's everything to build the product. Then you'll have a certain amount of gross profit that you make, assuming you sell it at a wholesale price, say to a retail chain. Most of the customers we have are start out selling direct, frequently as a result of a crowdfunding campaign. But if they hit it big, they're going to be selling through retail. There are exceptions, of course, but that's usually what happens. Okay, and then the retailer makes a profit. And that's the difference between the wholesale price and the retail price. Now, one thing not included in here is actually the cost of returns, warranty, and customer support. This is another thing people don't think about at all unless they've been through this particular rigor before. It's not uncommon, it's perfectly common for the cost of warranties, returns, sending out spare parts, customer service, spending time on the phone with your customers who don't understand, that you don't take the 2 spare vacuum filters and jam them into the vacuum on top of the existing standard filter already there, which happens all the time. And this is typically 10%. And keep in mind that, as I mentioned before, a well-run consumer products company makes about 10% of the bottom line. So if that 10% becomes 20%, and it easily can, and it happened to us at iRobot, all of a sudden you make no profit. And no profit doesn't mean you're not growing, it means you're laying people off, because you need profit just to keep the business going at the current level, never mind expand. Things that drive COGS, most important is your design. A lot of people want to go to a cast aluminum or metal enclosure, and they think of things like iPhones, which have these nice metal enclosures, but iPhones are made millions per week, and they spend, and they're just, don't even hesitate to spend $20 million in custom capital equipment just to make the case quickly and cheaply, because their businesses are huge. Your business is not that huge, you can't do that stuff. So things like metal housings have a real cost penalty. So material and component selection, the fabrication method, efficiency, and this is probably the one that means the most. People design things that are hard to build. You've got to flip it over 10 times and put screws in from 12 directions, and you've got to have 3 hands with 8 fingers each to hold all of the parts into place. And if you're not careful, a wire slips out and gets pinched when the 2 case halves come together, and you've got a defective product. A good product you can assemble from one side and nothing gets pinched. You just stack everything up and drive 4 screws in and it's done. Quality requirements. This comes down to fit and finish and materials, and also reliability, because that drives how much money you pay. Does this robot run 500 hours in its life, and so an inexpensive brushed DC servo motor is good enough, or is it going to run 15,000 hours in its life and nothing less than a $100 brushless motor with special controls is going to do? Pack out. People want to throw in a lot of extra stuff. They say, oh, we want rechargeable batteries, so the user doesn't have to replace it. Well, rechargeable batteries are more expensive. You got to have a charger. If you're going with lithium batteries, you've got to have a battery management circuit. You've got to make sure you've chosen the right chemistry, that you've taken safety into account. Things, we've all seen pictures of the Dell laptops that went up in flames. You don't want that to happen to your customer. Your manufacturing partner, a lot of our clients will say, we want to manufacture in the US. And that's they're great to have an emotional attachment or a commitment to helping rejuvenate manufacturing in the US, but if you're in the volumes where you could build in China, you will pay on average about twice as much to build here in the US as in China. And think back to that cost of goods stack up where your competitors are all building in China, and it's basically a non-starter. There are some exceptions. We've had a couple of clients, 2 in fact, for example, building 3D printers, high-end 3D printers, $3,000 or more each, where the total labor content is 2 or 3 hours. At that point, it's actually cheaper to build it in the US. And the reason is the labor cost is so small as a percentage that when you add up the cost because if you manufacture in China, you've got to have staff there. You hire Dragon to do it, or you have your own staff. And you got to fly back and forth, and there's costs associated with language and time zone issues. And China manufacturing is cheap and has high volume capability, but it's often not very flexible. So if you have a business that needs flexibility in the US or even in Mexico, can do it. And any product in China is typically 5 weeks away from its market. Okay, when you're working with a manufacturing partner, there's something that's very important, BOM transparency. Left to their own devices, the manufacturer will quote, okay, your variable cost is $30 a unit, your fixed cost is $150,000, and that's it. And so if later on you say, okay, I can swap this motor for this motor, how much is it going to save me? And he'll say, oh, 10 cents. And you're thinking, well, I think it should be higher than that. But you can't argue with him because you don't know how much he paid for the original motor. When we have CMs quote a project, we require them to quote on a line item basis. Every piece of material, down to a piece of wire, a screw, a piece of tape, has a price, and it's in the quote. And also in the quote will be assembly labor, packaging labor, the packaging itself, and the markup. The markup is a percentage markup, and it contains their profit and overhead. And so that way you come back and you say they charged, originally quoted you 75 cents for the motor, and you swap the motor out, and you do your own sourcing, or we do it for you, and you say, we can get 50 cents in those volumes. So you know you're going to get 25 cents saving, plus the markup portion of the 25 cents. So you might save almost 30 cents. We'll talk about the profit margin a little bit later. Labor rate will vary a little bit by country, but you're typically choosing country by capability within reason. You know, China's running about $4 an hour for general assembly labor now, fully loaded. You go to Vietnam and probably get $1 an hour, but you won't be able to get your parts there. And you won't be able to hire engineers there and so on. Currency, typically prices are quoted in US dollars, but the usually contract includes a provision that if the exchange rate shifts by more than X%, then they get to requote accordingly. Geographic location, shipping and tariffs, capability, this is important. If you have a good factory, you have a problem, parts aren't passing final test, a good factory, their engineers will tear into it and they'll say, you know, you need to add this cap on this line to filter out this noise, or you need a transorb here or something like that. A factory without the capability just say, oh, it doesn't work, we don't know why. And so they'll ship you a sample, you test it here and it works fine. So you don't know what's going on. And you have to fly your engineers over. Meanwhile, weeks go by. At iRobot, when we built the, I guess it was the 3rd generation robot, well, actually 5th, and we had the factory building power supplies for us, build us. We basically had, we had a universal power supply, 100 to 240, 50, 60 hertz, and we had a 120 volt, 60 hertz for the US and Canada. And everything worked fine. And then we went to sell in Australia, and it wouldn't work, wouldn't charge. Big black highway distributor. Turns out that at 120 volt, or 240 volts and 60 hertz like you get in Europe, works fine. You go to 240 volt, 50 hertz, then there was this little bit of electrical noise that the power supply generated, switching power supply, that was just the right frequency. When it got inside the robot, flipped out the processor. The processor stuck its 4 little paws in the air and refused to charge, which is the right thing to do to be safe. You know, anything wrong, you don't charge. There's watchdog timers in there that once the processor locks up, it turns off charging. Because we just hadn't tested all 4 permutations of voltage and current. So, and that's something, you get those funky problems, and if you're flying people back and forth to fix them, it'll kill you. One factory we worked with, their electrical engineers, who were mainly manufacturing engineers, they were just awesome. There were many times when we had, you know, the really good quality engineers here in the US unable to fix a problem. So one guy, Marco, would dig into it and he'd figure it out every time. And so that's really important, and oftentimes you won't go with lowest bidder. You'll go with the factory that has, you know, the best engineering department. Supply chain, so a lot of this depends on, sometimes a bigger factory can often get better pricing on parts for you. Some of the factories will have good relationships. If they've built products a lot like yours, then their supply chain will be well established. If they've not built a product like yours before, they may have to find vendors for the first time. And without a history with those vendors, they won't have the kind of leverage that they have when they know that this factory's bought $500,000 of stuff worth from me in the last 5 years. I better treat them right, as opposed to a new guy I might never see again. Okay, plastic costs. Most of the products we build in China for people contain molded plastic. So here you have a gear. Does it matter if it's a gear?
Injection molding works the same for whatever shape it is.
Okay.
It doesn't really matter.
Yeah, you got to be a little pickier about gears and setting them process parameters. You don't want any deformation. There's 3 components. There's the material cost. That's not just the weight of the part times the cost of the resin. Yeah, ABS, you know, at the price you pay at the factory might be $2.40 per kilogram. And when you get into elastomers, it climbs. You know, you might pay up to $6 for Santoprene and so on. So that's kind of important. And most molded parts are roughly 50-50 materials, and then the other charge, which is the machine overhead and labor. And so there's an hourly cost. So an 80-ton press that does a tiny part might be about $10 an hour for labor and machine time. And a 380-ton press that does, you know, part about this big might be $30 an hour. And so that works with the cycle time, so that a big part through that 380-ton press might have a cycle time of 60 seconds. And so, you get out 60 in an hour, $30 an hour, that's 50 cents just due to the cycle time. And there might be, say, $1 worth of material, so the part is $1.50. There are ways to attack this. You build a tool with multiple cavities in it, say it can make 4 parts at once. Then you get 4 parts out every time it cycles, and so the cost per part goes down by a factor of 4. Factory markup, scrap, and overhead. So this is a percentage, and we'll go over some of that in a little bit. So the total cost is just a sum of those 3. Cost of BOM, cost of goods, sum of the parts. No mystery meat. By that we mean you don't want a quote that says your variable cost of $30. What's in it? What's the markup? You don't know. What's in a bill of material? Plastic parts, other manufactured components, sheet metal, stampings, forgings, castings, machine parts, mechanical purchase parts, screws, motors, electrical components, all the components that go on a PC board. Consigned components, and this is important, there are 3 categories of components. There are commercial components, assigned, and consigned components. Commercial components are things you don't care about. You say screw, stainless, 3mm, M3 by 5mm Phillips head. And you just don't care where he buys it, as long as it meets that spec and so on. And it's up to the factory to find the lowest cost producer. He may change week to week as his sourcing team decides, and you don't care. An assigned component is one which the factory's going to buy, and he's going to stock it, manage it, but he's not allowed to choose a different part. A great example for this is a processor, right? You've chosen Intel processor XYZ, and it goes in a high temperature environment, so you choose all the right prefixes and suffixes for a higher temperature rating, and maybe you wanted a different packaging, ceramic packaging, because it's in a rugged environment. Maybe this thing goes under the hood of a car. You don't want him saving money by switching to the cheap plastic part with the lowest temperature rating, which saves him $1, but the thing's going to fail in the field like popcorn. So that is an assigned component. And for example, with components like that, that goes on the critical to quality list. And when we inspect a shipment, we'll take a sample and we'll tear it apart. We'll actually read the part numbers off the chips against a list of these parts. Then there are consigned components. And these are components that not only have you chosen them, you're actually going to buy them and you're going to have them shipped to the factory in time to meet their schedule. And it's a royal pain in the butt, and you generally never do it, with a couple of exceptions. And the first and most important is one having to do with IP. At iRobot, the key part of the robot from an IP point of view was the software. Nothing mechanical was new since like 1955. All the value was in the software. And in fact, of the 3 knockoffs we know of that existed, all 3 failed in the marketplace because they couldn't copy our software, and the software was hard. And they wrote their own and it sucked. So they just flopped. So what we had done was our software was encrypted when it's loaded onto the chip. A decrypting bootloader already on the processor would decrypt it on the fly. And so we could send code updates to the factory as an email attachment. We could have posted it on the internet. We didn't care. It was encoded with 128-bit encryption. But the family jewels were the decrypting bootloader. So we had that loaded onto the processor in a lab in Singapore that the factory didn't know where it was. And then we'd have it blind shipped to the factory. And the bootloader, once it was stable, hardly ever had to be updated. So that didn't need to be flashed to the field. And so for that reason, we had to consign the parts because we couldn't allow the factory to know the supply chain. Eventually, we came to trust that factory, and we put the bootloader on right in their facility. But that was after millions of robots went out the door, and we had a lot of trust in them. But in the beginning, so we consigned those parts. What that meant was, as we worked with the factory on forecast and production planning, we had to have staff in the U.S. working with our vendors to decide when to ship this stuff, and you're operating a chunk of a factory purchasing department. So you really don't want to do it. The other place we did it was with batteries. The quality of the rechargeable battery was about 30% of the cost of a Roomba, and the quality of the battery was paramount. We hadn't gotten good results from working through the factories because they just didn't have the technical experience with rechargeable batteries. So I ended up choosing a vendor. We did a competitive bake-off, working with a vendor which actually was a French company that had Chinese factories they worked with, and they had extremely competent quality control people in their own test labs and so on. And so we worked that out. So again, we had to manage the supply chain. So you don't want to do it unless you're absolutely forced to. Decoration, so pad printing, screen printing, engraving, things like that, all add to the cost. Painting especially, always try to avoid paint. It can look beautiful, but the thing about painting is you can paint 1 million units in a row, and the 1,000,001st can get screwed up and then get shipped. Whereas if you mold the color in, once you get the parameters right, it pretty much just runs and they're always good. So, and plus paint can get scratched. It has to be handled so carefully through the factory you've got to have nests and pads and disposable covers for all the fixtures. So, yeah, we're packaging. Say everyone wants to have an unboxing experience like an Apple product. Say you've got a box about this big, and you want to have this beautiful multi-layer flaps that fold out and the inner box comes out. You could easily spend $4 on that package, and that's in high volume in China. And you're doing this for a product that maybe has a cost of goods of $20. You just added 20% because you wanted a fancy box. And if you're fulfilling a Kickstarter campaign or you're selling direct, there's almost no reason to do anything like that. Assembly labor frequently runs about 15 to 20% of the total cost because China's labor costs are going up. You could double it, you could cut it in half with intelligent design. Remember I talked about the product that has 20 screws in it? You keep flipping it over, and you gotta adjust things and hold it down with your third hand while you tighten the screw. Whereas if you make something that goes together in a stack and everything is self-jigging, so a baboon could put it together and get it right the first time, the workers will whip through that so faster, your hands are a blur, and it'll go together right every time. Profit for the factory overhead and scrap, that's typically a percentage. You can negotiate a little bit on it, but for the most part, you don't have too much elbow room there. Overland transportation to the port, again, it's got to be there, but you don't have much elbow room in changing it. Profit margins, if you just build a PC board assembly, because it's so heavily automated, 6 to 8%. Toys, maybe 12% markup, mainly because it's so cutthroat.
Can you define what all those acronyms are? What's PRC, what's CM, what's PCBA?
People's Republic of China.
Okay.
Contract manufacturer.
Got it.
PCBA, printed circuit board assembly. Medical devices, 20 to 40%. The people we work with are in the low 20s for the most part because we don't build any medical devices that could hurt somebody. So blood glucometers, thermometers, stuff like that. And they typically around 22 to 24%. Typical resin prices, these are wholesale prices, you gotta add 20%, and they're in US dollars per metric ton. So if you want dollars per kilogram, you just divide by 1,000. And whereas ABS, $1.80 plus say 20% at least, and you go to polycarbonate, you're up to $2.70, $2.80. Santa Cream, $5.40 plus 20%, easily into the sixes.
Because the price of oil is going up and down, do they have a deadband on those prices?
I think they're live. I think you'll always get a different price. What's Santa Cream is a brand name. That's one of the reasons it's so expensive. There were generic versions of it available that cost about half as much. They're not quite as good. So as much as possible, you try to work with the generic materials, but sometimes you have to go with the name brand to get a special quality. Molding rates. I talked earlier about 80-ton press, $10 an hour. 368-ton press, $30 an hour. EE costs, you have cost of components and usage. You always want to, the high-cost components, the $20 graphics processor, et cetera, you want to demand a lower markup from the factory. Why the markup? Cash flow and payment terms is important. And I gave that example way back in the beginning where, Target says I want 100,000, and it's going to cost you $3 million to have built, and you're not going to get paid for 5 months. You got to come up with the cash to deal with that in the meantime. After a year of operation with the factory decides you're good guys and you're a good risk, and they'll give you terms. So they'll give you 30 days terms. So now you pay for it here, and I don't know why the green arrow is here. Maybe there you got in this example, Scott figured you get better terms from the retailer. So now you've brought the time you have to cover for down to only 6 weeks. There have been cases where somebody has a hot new product that's in demand, and they get an agreement from a retailer to get paid in advance, or even to invest in the company. That does happen. It's not going to happen routinely, though. Okay, payment terms, we talked about roughly half at receipt of the PO, and the other remainder ex-factory date. Tooling, typically half when they start the tools, and the other half upon acceptance, which is typically around the beginning of engineering pilot. Sometimes it's slightly before that. So basically, you cough up half the cost of the tools. The tools are machined, they run test parts. We inspect them, we make changes if needed. Then you inspect them, you demand changes if needed. Once everyone agrees they're good, they're signed off and you pay the other half. NRE, non-recurring engineering charges, this will vary some. Typically, it's right after signing the contract. Not uncommon to see 20 to 50,000 for an NRE for manufacturing the Pearl River Delta. You go to Taiwan. We have one client who had their product quoted at a tier 1 factory in Taiwan. The NRE was $560,000. We went to a factory in the Pearl River Delta. They quoted $50,000. And the guys in the PRD are willing to take a chance and basically cover much of the non-recurring charges. and make it back from profits. Whereas the Taiwanese, who used to be like that, say a generation ago, now they're careful and they want it such that if you drop dead tomorrow, they aren't out any money. So retail terms, anywhere from net 30 to 120. That's pretty much it for costing.